The evolution of wireless communication, 5G versus 4G. Introduction. In the ever-evolving landscape of wireless communication, 4G and 5G stand as two significant milestones that have revolutionized how we connect, communicate, and consume content. While 4G brought about a surge in mobile internet speeds and enabled the proliferation of smartphones, 5G is poised to transform entire industries with its unprecedented speed, low latency, and massive connectivity capabilities. This article delves into the differences between 4G and 5G, examining their advantages, disadvantages, and the key players behind their development. 1. The birth of 4G, a leap in connectivity. 4G, short for fourth generation, was a significant upgrade from the earlier 3G networks, which were primarily focused on voice and basic data services. Introduced in the late 2000s, 4G technology was designed to meet the increasing demand for high-speed mobile internet and multimedia applications. Key features of 4G. 1. High data speeds. 4G networks can deliver download speeds ranging from 100 megabits per second to 1 gigabit per second, depending on the specific implementation. 1. This was a game changer for streaming video content, online gaming, and other data-intensive applications. 2. Low latency. 4G significantly reduced the latency experienced in 3G networks, making real-time communication, such as video calls and online gaming, much smoother. 3. OFDM, orthogonal frequency division multiplexing. 4G networks use OFDM technology, which allows for efficient use of the available spectrum and supports higher data rates. 4. Global adoption. 4G quickly became the standard for mobile communication, with widespread adoption across the globe. Advantages of 4G. 1. Enhanced mobile experience. The introduction of 4G brought about a significant improvement in the mobile internet experience. 1. Users could stream high-definition videos, engage in video calls, and download large files with ease. 2. Broad coverage. 4G networks were rolled out across urban and rural areas, providing broader coverage compared to earlier generations. 3. Cost-effective. As the technology matured, 4G services became more affordable, making high-speed internet accessible to a larger population. Disadvantages of 4G. 1. Network congestion. With the increasing number of users and data-hungry applications, 4G networks often faced congestion issues, leading to slower speeds during peak times. 2. Energy consumption. 4G networks, while efficient, still required significant energy to operate, leading to shorter battery life for mobile devices. 3. Limited IoT support. Although 4G supports IoT, Internet of Things, devices, it wasn't specifically designed for the massive number of IoT connections that are now being deployed. 2. The advent of 5G, beyond speed. 5G, or fifth generation, is not just an incremental improvement over 4G, it represents a paradigm shift in how wireless networks operate. Officially launched in 2019, 5G is designed to address the shortcomings of 4G while opening up new possibilities for industries and consumers alike. Key features of 5G. 1. Ultra-high data speeds. 5G networks can achieve download speeds of up to 10 gigabits per second, far surpassing the capabilities of 4G. 1. This allows for seamless streaming of 4K and 8K videos, as well as immersive virtual and augmented reality experiences. 2. Low latency. 5G reduces latency to as low as 1 millisecond, enabling real-time communication for critical applications such as autonomous vehicles, remote surgery, and industrial automation. 3. Massive device connectivity. 5G is designed to support up to 1 million devices per square kilometer, making it ideal for the growing number of IoT devices and smart city applications. 4. Network slicing. 5G networks can be segmented into slices to provide dedicated resources for specific applications, ensuring optimal performance for different use cases. 5. Energy efficiency. 5G networks are more energy efficient than 4G, extending the battery life of connected devices and reducing the overall energy consumption of the network. Advantages of 5G. 1. Transformative speed. The most obvious advantage of 5G is its incredible speed, which allows for instant downloads, high-quality streaming, and lag-free gaming experiences. 2. Support for emerging technologies. 5G is the backbone for future technologies such as autonomous vehicles, smart cities, and advanced IoT applications. 2. Its low latency and high reliability make it ideal for critical applications. 3. Improved network capacity. With its ability to support a vast number of devices, 5G alleviates the congestion issues faced by 4G networks, ensuring a consistent user experience even in densely populated areas. 4. Enhanced mobile broadband. 5G enhances mobile broadband services, making it possible to use mobile devices for tasks that previously required a wired connection, such as high-definition video conferencing and cloud computing. Disadvantages of 5G. 1. Limited coverage. As of now, 5G networks are primarily available in urban areas, with limited coverage in rural regions. 1. Building out 5G infrastructure, especially the millimeter wave technology that enables the highest speeds, is a costly and time-consuming process. 2. Interference issues. 5G, particularly in the higher frequency bands, millimeter wave, is more susceptible to interference from obstacles like buildings and trees. 2. This necessitates the deployment of more small cells and other infrastructure to ensure consistent coverage. 3. Cost of implementation. The deployment of 5G networks requires significant investment in new infrastructure, including the installation of new antennas and base stations. 3. This cost is often passed on to consumers in the form of higher service fees. 4. Security concerns. As with any new technology, 5G introduces new security challenges. 4. The increased number of connected devices and the complexity of the network create more potential vulnerabilities that need to be addressed. 3. The pioneers behind 4G and 5G. The development of 4G and 5G technologies was the result of collaboration between numerous companies, organizations, and governments. Key players in the development of these technologies include 4G development. 1. ITU, International Telecommunication Union. The ITU played a crucial role in defining the standards for 4G networks. 1. The organization set the requirements for data speed and other technical specifications that 4G networks had to meet. 2. 3GPP, Third Generation Partnership Project. This organization, which brings together telecommunication standards bodies, was responsible for developing the LTE, long-term evolution, standard that became synonymous with 4G. 3. Nokia, Ericsson, and Qualcomm. These companies were instrumental in developing the hardware and software necessary for 4G networks. 3. Qualcomm, in particular, played a key role in developing the LTE modem technology used in 4G devices. 5G development. 1. 3GPP. As with 4G, 3GPP has been at the forefront of developing the standards for 5G networks. 1. The organization has released multiple versions of the 5G standard, each adding new capabilities and refinements. 2. Huawei, Ericsson, Nokia, Qualcomm, and Samsung. These companies have been leading the charge in developing 5G technology. 2. Huawei and Ericsson, in particular, have been heavily involved in the deployment of 5G infrastructure, while Qualcomm and Samsung have developed the chipsets and devices that support 5G connectivity. 3. Government initiatives. Governments around the world, including those in the United States, China, South Korea, and Europe, have invested heavily in the development and deployment of 5G networks. 3. These investments have included funding for research, spectrum allocation, and infrastructure development. 4. The impact of 5G on industries and society. The introduction of 5G is expected to have a profound impact on various industries and society as a whole. Some of the key areas where 5G is expected to make a difference include healthcare. 1. Remote surgery. With its ultra-low latency and high reliability, 5G enables remote surgery, where surgeons can operate on patients from miles away using robotic systems. 1. This could revolutionize healthcare, particularly in rural and underserved areas. 2. Telemedicine. 5G supports high-quality video conferencing, enabling doctors to diagnose and treat patients remotely. 2. This could improve access to healthcare services and reduce the need for in-person visits. Transportation. 1. Autonomous vehicles. 5G is a critical enabler of autonomous vehicles, providing the real-time communication needed for vehicles to navigate safely and efficiently. 2. Smart traffic management. 5G can be used to create intelligent traffic management systems that reduce congestion, improve safety, and minimize environmental impact. Manufacturing. 1. Industry 4.0. 5G is a key component of Industry 4.0, which involves the use of advanced technologies such as IoT, AI, and robotics to create smart factories. 1. These factories are more efficient, flexible, and capable of producing customized products on demand. 2. Supply chain optimization. 5G enables real-time tracking of goods and assets, improving supply chain efficiency and reducing the risk of delays and losses. Entertainment. 1. Augmented and virtual reality. 5G's high speed and low latency make it possible to deliver immersive AR and VR experiences, opening up new possibilities in gaming, entertainment, and education. 2. Cloud gaming. 5G enables cloud gaming, where games are streamed from the cloud rather than being run on local devices. 2. This allows for high-quality gaming experiences on mobile devices without the need for expensive hardware. 5. Conclusion. The transition from 4G to 5G represents more than just a speed upgrade. It is a fundamental shift in how we connect and 4.0.